Hi friends, so now I'm back with my next video, and in this video we are going to talk about mass spectrometry. Please make sure to like, share and subscribe my channel. So what we are going to talk about today is mass spectrometry. So what is mass spectrometry? What is the principle behind it? And what are the advantages of using a mass spectrometry? So if you know the mass spectrometry, it's an analytical technique which is used to identify and quantify the amount of substance in a sample. So as an example, suppose you have your suppose someone is suffering from some disease like the metabolic deficiency disease, in which either one enzyme is not present or one of the protein sample is not present on some important chemicals which are required for your body to work is not present. So how can you identify that? And the technique that is commonly used is mass spectrometry. So how does it work? It's based on the mass to charge ratio of ions. So suppose we are talking about one sample in which you want to identify the enzyme which is present or not. So suppose we are talking about glucagon. So glucagon is important for producing glucose, and if you don't have this glucagon present in your body, then some people can have like the deficiency of the glucose, like they can have hypoglycemia. And what this technique do is, so you have the molecular weight of this compound, you have the formula and the molecular weight, and different isotopes like have different weight, right? Because if you know this isotope, they have the same number of neutrons, but the protons can be different. And then the most abundant, which is normally found, mass. So what you can do is you run the sample from that person in this machine, which is mass spectrometry. And then this is what it gives you, the abundance of that protein of the or abundance of glucagon or abundance of a particular chemical sample that you want to identify, and mass. So sometimes this mostly that you will see is mass to charge ratio. And based on that, you can identify in a particular sample how abundant is particular sample is based on their mass, because if you know different compounds have different mass and they generate different ions when they are ionized, and based on that you can identify if that protein or if that chemical is present in your sample or not, and if it is present at what amount is it's present, right? And based on this you can check if some person have deficiency for one of the chemical, or if it is present or it is produced in abundance amount or not, right? So this chemical maybe you know, or sometimes it's unknown, like you just pass a sample for which you don't know the what compound it contains, and based on the molecular weight, molecular mass, you can identify that. So this technique is very useful when you want to quantify and identify the amount of substance. And how it works is mass to charge ratio of ions, that I will explain now in my next slide how it works. So now we know why it is used, and now comes the principle. How does it work? So this is the machine, or this is the basic principle of mass spectrometry. Suppose you have one sample and you pass this sample through a gas sample. So for this to work, the sample should be in the gaseous phase. Why does it matter? So there is this sample that you inject, which become vaporized and like the by the heater, and it needs to be in the gaseous phase, because otherwise it can like it cannot pass through this plate, and it cannot go in the electric field, which is very important, because the liquid will evaporize if passed through these. So the sample needs to be in a gaseous phase so that it can be accelerated through this electric field. And then the another thing which is very important, that it needs to be in a vacuum chamber. So if the sample is not passed through a vacuum, so suppose there is no vacuum inside these, then this molecule can collide with the air, and then it's very difficult to identify the compound and thing and to know the abundance. Because if it collides with air, it's very difficult to generate ions and to then to quantify. That's why the sample needs to be in a vacuum, inside the vacuum for to be its detection. And the important thing is that it needs to be in a gaseous phase to be detected. So once it is in the gaseous phase and it's in the vacuum, then when it passes, the electron beam is passed through this. So you see, so the electron beam, which is the ionization source, which can be from the electron like from the electric spray ionization, or it can be like the chemical ionization, like some chemicals which will cause this ionization. So what does it means is that when you have the sample, you need to generate it into an ion. Why? Because if you see these electric plates, they all are charged. The magnetic field, the electric. So for the sample to move through here to here, like to the detector, the ions should be there which can be accelerated, because if it's not in the ionic form, it cannot pass through this plate, right? So it needs to be ionized, which means we need to release, like make it charged, which can be positively charged or which can be negatively charged. But most of the time, which you will know in mass spectrometry, is positively charged ion. So what happens? When an electric field or the chemicals, there are some chemicals like NH4, when they also react with the molecule and then they cause the release of an proton, like make a positively charged, like or the release of an electron, which makes it a positively charged. So all this electron beam, electric ionization, chemical ionization, or there are different type of this ionization source which are present, and when they hit the sample, they releases the electron and become positively charged. And these positive charged ions are very important for the detection, because then only they can pass through the electric field. And they can generate through this beam different molecules. So suppose your molecule is like it's 198 kilodal, like 198, the mass is 198. And when an electron is released, it can release one electron, two electrons, so it can become positive, two positive, three positive, or like these beams, they are so strong that sometimes they can fragment your molecule. So suppose it's a 5 carbon and it will fragment it into 3 and 2 with the positive charge. So based on these beams, you are not sure if how many fragments it will generate, right? So it can generate multiple fragments which then pass through this detection, because the fragments will be positively charged, right? And when the ions are generated, then they pass because they are positively charged, and these plates that you see, they are also positively charged. So they pass through here, right? And then these are electric plates, so the ions that get deflected. So the mass of the molecule divided by charge, because now they are positively charged. So depending on the charge and mass to charge ratio, they move through this electric plate, and then there is this magnetic field. So there is this magnet which releases the magnetic field. And based on this magnetic field, they get past the detector. So because the charge, because they are positively charged, so they will be deflected in the same direction, because if they are negatively charged, they will be directed in the another direction. But mostly, as I told you, in mass spectrometry, we are mostly talking about the charge which is positive. So they get passed through this magnetic field, which is positively charged ions. And then what is the difference is mass, right? So based on the difference in mass, they reach the detector at different places. So suppose a molecule which is like the more heavier, like have more mass, so that molecule will be deflected less from the magnetic field. So this molecule will be the top one. And then the lower mass, the molecule with less mass, it will be deflected the most. So it will come here. So this deflection depends on the mass. So suppose if you have one molecule which is so abundant and then the mass is same, so then you will get all the abundance here, and there are detectors present which detect how much is coming from which deflection. So if it's less mass, it will be deflected here, and if it's more mass, it will be deflected here. And based on that, you get a spectrum, like I told you about this. So like the abundance you see, it's of the high molecular weight, like here. This one is the high molecular weight, so it will be near the deflection, like this will be here. And the one with the lower molecular weight will be deflected more. So based on this, you get the your molecule in different fragments, and then you can identify the abundance of that molecule. So now that we have talked about the principle, how it works, so now we can go ahead with the advantages of this technique. So first thing is you don't need so many sample. It works even with a very small sample size. So this is very important because sometimes you don't get enough sample to work with different techniques, but with mass spectrometry, it's very simple. And then it is very faster, like this technique, and then you can get the sample, and it's very fast that you can do this technique very often, like it's much used in research. And then the important thing is it is very capable of differentiating different isotopes. Like I have talked about some molecular mass, so they are like different mass, like carbon 12, carbon 14, oxygen 16, oxygen 18. Different techniques, they are not able to differentiate between different isotopes. But with mass spectrometry, it is possible because it works with the mass to charge ratio. So you can differentiate different isotopes as well. And then it's very sensitive. Like even if the small abundance of protein, like I have shown you in for the glucagon, even with very small like even if the quantity is very small, it can be detected with this machine, with this technique. And then it is a perfect tool to identify the presence or absence, as we have talked about. So this is very important, and it's very this technique is very advantageous, and it's used in research very much. So I hope it's clear. And if you have any doubts, please let me know in the comment section. And please don't forget to like, share, and subscribe my channel. Thank you.